Hello, this is Eric Topol with Medscape's Medicine and the Machine podcast. And we've got a special guest today, Dr. Isaac or Zach Kohane from Harvard, who is a pediatric endocrinologist and leads the bioinformatics there. He's a pioneer in this whole field and one of the people I really look up to. So Zach, welcome.
Thank you, Eric. It's really great to be on your podcast.
Well, it's a natural because as you, I think, remember recently, I had the interview with Peter Lee and the book that you and he wrote together with Carrie Goldberg about GPT-4. So you had several months to kind of test drive this. And before we get into GPT-4, I wanted to retrace the history a bit with you because I think a lot of our audience doesn't really understand this progression. So let's go back to the old world of convolutional neural networks, AlexNet, 2012, approximately a decade ago, because kind of that's where we were in medicine and healthcare. So that then changed with the transformer architecture in 2017.
That's correct.
So can you kind of describe what did we have with deep learning models and what changed when a new model of transformers came along?
So I can't help but say, for the sake of the audience and for my own sanity, since I also got a PhD in computer science in the 1980s, working on artificial intelligence, I have to say that we tried to have the impact in AI 30 years ago. And for a variety of reasons, we failed because we didn't have the right data on patients, because we didn't have the right data on medicine, and because neural network models were super simple and we didn't have the compute. So things began to change in 2012. And we were already pretty impressed, all of us, that around 2018, we started seeing in the medical literature the consequences of these convolutional neural networks, that they could actually detect changes in images that were perhaps imperceptible to humans, that would allow them to not only diagnose, for example, retinopathy in the back of the eye, but could tell you what the sex of the patient was, their age, what other diseases they had. And so there were a bunch of these applications, mostly image-based applications, but also some applications related to time series and health records that had impressive performance. But what was different, what was characteristic of them, is that they were very purpose-built. You train them up for a specific purpose, diagnosing retinopathy, predicting time to readmission. These were programs that not only were purpose-built, but because of that, you could evaluate pretty easily. Did it, in fact, what was the accuracy for that specific task? Then what happens around 2017, as you point out, is a paper that came out of Google for us, this transformers architecture, which allowed us to create these models that you could fine-tune for a pretty generic task, like tell me what's the next word I'm going to say, or most likely to say after this string of words. What was interesting about these models, they were built not for a given purpose. They were essentially built on the joint probabilities across a large corpus, in this case words, across everything that human beings have said on the internet. And as we might get to, similar kinds of things were done for amino acid sequence, a very different kind of language. And in both cases, the transformer model allowed us to take these generic models in the sense that, and these sometimes called foundation models, they were not built for a specific purpose. And you could then train them to do certain tasks that are relatively generic. Again, like predicting the next word that would be said, or that would, for example, predict the effect of a mutation on a change in amino acid. And frankly, we all thought it was interesting, but if you followed the literature around 2018, 2019, 2020, as these models got bigger, we were increasingly impressed. But if you'd asked most of us, certainly if you'd asked me, when would these start becoming useful in medicine? I would have said in about 10 years at the earliest. And I think we were just not data driven. If we had really been looking at, for example, at OpenAI, the original GPT and then GPT-2 and GPT-3, if we had actually been following the increase in performance, we should have concluded that GPT-4 was going to be really impressive. But you could not imagine, and it's still hard to understand, how something that has not been trained on medicine, for example, just saying that it knows the next word I'm going to say and the next word after that, somehow I can have a conversation with it about a case of ambiguous genitalia. It's hard to understand how that's the case. And so even though we could have followed that growth from GPT-3 to 4 and say, this is going to have human-like performance on many tasks, you could not imagine it. So most of us were taken by surprise.
Yeah, and just before we get to really what took the world by storm, ChatGPT, in end of November, with well over 1 billion users, unique users in 90 days, which is incredible, right? But I wanted to go back about the transformer model because this attention issue is what's central. And as you say, you couldn't have predicted it. But would you say that the prior deep learning models, deep neural networks, the inputs were just not organized? Didn't have these tokens. They didn't have a way to basically do this prediction and look like it was so conversational? What is it about the way this model's architecture that made it so uniquely different and was kind of a sleeping giant waiting to unfold as OpenAI and others really built on it?
So I think understanding more about the context of any given word or 2 words or 3 words, understanding context so that and that context could become longer and longer, depending on how much computer power, that kind of intention. So rather than saying that the word is co-occurring, but where it co-occurs in a sentence, that difference, I think, made the difference between the other models, previous models, would have eventually gotten there, but it probably would have taken 2 or 3 or 4 orders of magnitude more growth. Just that simple insight, the attention mechanism, which says where these strings of tokens. We had tokens before. We had these recurrent neural networks, which allowed you to predict to a certain extent what was the next step in the emergency room and treatment. They kind of worked, but they sort of worked like GPT-1, and they're very inefficient. And so this notion of the context that you get from attention allowed it to be very efficient. You still had to create this. We don't know how big GPT-4 is, but it's at least a 1 trillion parameter model. And if we'd used the other technologies, we would probably need something 10 times or 100 times bigger to work. So that just gave us efficiency. Everything has always been improving in machine learning with scale. And this just gave us an additional acceleration several generations. And so, yes, the attention model did matter a lot. And of course, the irony is not lost that this was developed in Google, but Microsoft, through its investment in OpenAI, seems at least temporarily to be the major beneficiary.
Yeah, no, it's a fascinating story when you look back, not wanting to challenge search as it existed, and now kind of the resurrection of Bing to a whole nother level. So then we have essentially 9 orders of magnitude increase in floating petaflops of computing power. We put in all the internet, Wikipedia, gazillion books, every input you can imagine, and we feed in what eventually becomes GPT-4, which is released mid-March this year, only months after ChatGPT. And now we have even more powerful large language model. And the difference here, if you can comment, Zach, it's not just a large language model, it's multimodal. That is, it works with images, it works with speech, and this really is important as it relates to medicine, where we don't just use images, and we now can look at unstructured text along with ambient voice or speech, along with videos. Tell us what about GPT-4, because it is a big jump from ChatGPT and other large language models. There are many of them out there, of course. What is it that, besides the fact that it's got more parameters and more everything, that this multimodal story, if you could kind of develop that?
So I'm going to agree and then disagree. So I do agree that the strength of these multimodal approaches is going to really accelerate what chatbots like GPT-4 can do. But I actually don't think that's where its strength comes from. And what's fascinating is that Sam Altman has hinted at this, but the contents, the details are secret. And I think it goes something like this. There's a bunch of details about the way it was implemented at that scale that have not been shared publicly. Some of it's engineering, some of it is babysitting. I've heard through the rumor mill, for example, these models are not guaranteed to converge. In other words, they're not guaranteed to have a stable solution. And it was the case that they ran it large number of times, and I don't know how many times, before it actually converged. And there was no guarantee ahead of time, which is pretty scary, because each one of these runs probably cost a few $1 million just in electricity to run. So that's one part of it. And the other part of it is the alignment process. And I think that's incredibly important. The fact that GPT-4 and GPT-3.5, which was the original ChatGPT, can actually generate exactly what they're built to, but create completely uninteresting phrases, could create syntactically correct sentences that represent the probabilities correctly, but are completely uninteresting to humans. That problem went away with a surprisingly small number of alignment procedures. The alignment procedure that we've heard about most is what they call reinforcement learning through human feedback, where basically you start it by giving lots of examples of the right prompt and lots of examples of the right response, and then you start grading its responses to prompts. And apparently this was done relatively cheaply with people hired in Africa, actually, to create these cases and then to grade the responses. And we don't know the numbers, but it was not billions. It was probably tens of thousands or maybe hundreds of thousands of examples. That's it. So tiny compared to the size of what's called the pre-trained model. And that has made a huge difference. And so I would say that the breakthrough that we seem to see with GPT-4 is probably actually only due to the size of the model plus the alignment. And there's an important paper that came out, and feel free to edit this out of the podcast. There's a paper that came out in Archive about what would they call it? It was the title, something like the mirage of emergent behavior. And what they were trying to say was, everybody's saying that this emergent intelligence all of a sudden appeared in GPT-4. And they say, no, it's actually not the case. What the metrics that we have been using, the measurements of GPT performance that we've had to date, have basically been either it's right or it's wrong. If you come close, if you get 3 out of 4 right, you don't get partial credit. And so what happened is these things started getting better and better. Didn't quite get to where it needed to get. But if you watch it across the models, as this paper describes, it actually was steady increase. It just got to the level, where it got things right enough so that the metrics said, hey, it's winning. And also got to the level where it was right enough so human beings say, hey, that's as smart as I am, maybe. Eric, I do think that the multimodal approach is going to be important. Frankly, I don't think that's where the strength of GPT-4 is right now. And I do think that we will see truly awe-inspiring wizardry when different modal AlphaFold is in a very different domain around protein structure and its dependence on amino acid sequence and a little bit of molecular dynamics and a little bit of coevolution constraints. But if you imagine those two things coming together, you'll have what we've been looking for so long, which is this ability to leap from molecular structure all the way to clinical impact. And that's going to be a superhuman performance. It's going to be, I think, hard to do. But one thing that seems to be true for the last 5 years is betting against performance increasing in this domain seems foolish.
Yeah, well, I think you're getting at my next line of questions, which is about this superhuman performance, or what, as you recall last year, there was a Google employee who eventually got fired because he thought the large language model was sentient. And now you have a Microsoft paper that talks about sparks of artificial
AI.
General intelligence.
Right.
It's the same thing that the Google person was being fired now. And the question, the fundamental question here, and of course as it relates to medicine, is have we reached a level of intelligence which is beyond the stochastic parrot, statistical context stuff that we were talking about? Have we reached a point where machines have gained a jump, maybe not to the point of all human cognitive tasks like AGI, but is it when you had all these months to test GPT-4, and since it is now out there in recent months, what are your thoughts about going to a new level of machine intelligence?
I think that this is a uncomfortable period for us because it's showing us how uneven our understanding is of what is intelligence. Because there are some things that GPT-4 can do diagnostically, where I've literally given it hard cases that in the undiagnosed disease network that I'm involved in were not diagnosed, that it could actually diagnose. And as doctors, we know that there are only fragments of medicine that we know well. And this knows a lot of medicine pretty well. It also makes very dumb mistakes, but it knows a lot. So what do you think of a colleague who is extremely knowledgeable about a lot of medicine, but also makes dumb mistakes and sometimes doesn't have common sense and sometimes makes stuff up? Is that not intelligent? We kind of know some people like that. The fact that the same thing give you a Torah interpretation or speculate on stock markets, I don't know what that is, but it's something that it's a property that we as humans pride ourselves on, and that we hire people because they have some of those properties. So I think that it gets us into the wrong rabbit hole to say, is this general intelligence? But it's certainly the kind of behavior and performance that historically and currently we still value in humans. And the weird part is it is foreseeable. This is going to get better.
Right. I think that's so critical. The range of applications in healthcare is extraordinary. So more of the mundane things like taking a conversation and a clinic visit and putting that in, not just into a note that's quite good, but also to all the downstream functions like, next appointment and follow-up tests and even nudging patients, as was discussed in the conversation. That one seems like that's near term, if you will, right?
Yep.
But then there's obviously the front door for physicians and nurse clinicians, whereby instead of having to talk to a doctor, they can just get their GPTX consult, and only when they're suspicious that it's not the right answer or the one they're looking for, or they need more, then they go. What do you think about that as a front door for answering questions and what we've seen, at least in a few reports, that there's, as you say, there's some hallucination or confabulation. Sometimes it's off, but for the most part, it's giving pretty good quality. The UCSD actually redid their study to look at accuracy. It was quite accurate. What do you think about the front door helper function?
For some reason, I'm reminded of something that you wrote in one of your books, and I can't remember which book it was, but I thought it was very insightful because it was so real, about how some people end up on boards of hospitals because they want to be able to get the right answer to the right questions.
Right.
And I think that privilege, everybody wants it, but because primary care is decimated in this country and it will not improve, the wish to have some authoritative answer and to be able to ask questions that your primary care doctor, assuming you have one, has not had time to answer or did not answer, is going to drive a lot of that kind of front door use, whether we like it or not. Already we're using, quote, Dr. Google to do searches to a lot of sometimes not particularly reputable websites to get information, just because there's such a need to get the right answers, because you're not getting the discussion you need. Sometimes because the doctor doesn't have time, sometimes because you don't think of the questions until after you've seen the doctor. I do think that in the absence, because of the fact that medicine is still very much a labor-intensive process, we're not going to be able to scale it up the way we want to. And so we're going to have to use more and more paraprofessionals. And having these paraprofessionals augmented with having a large language model look over their shoulder and catch errors, remind them, have you thought about this? Summarize the patient so that, for example, a PA can know all the detailed high-tech medicine that maybe the PA doesn't know. As you well know, because you've written about this as well, primary care doctors don't know very much about genomics. You can have that primary care doctor or PA with a large language model of his shoulder saying, this person has a family history of this kind of cancer. Maybe you should do the test. How often does that happen these days? Not often enough. Now, with these models looking over the shoulder, I think the front door is there. The only question is, are we going to be proactive enough as a medical establishment to make that part of the process? If not, then at least two other things could happen. One, patients will just start using it more and more because without doctor supervision, which has its risks, but in the absence of better alternatives, that's the way they go. Or there'll be new companies, whether it's a One Medical-like company through Amazon, where they really integrate this kind of support into the entire process, both for the doctor's side and for the patient side. So the question is, are our august, reputable healthcare systems going to embrace it? We'll see.
Well, that's a critical question because in some domains it's seen as a threat or not validated. I think there's some legitimate concerns about, because of the mistakes that are made, relative inability for patients, at the least, no less some clinicians, to differentiate the really great answers and conversations and outputs versus the ones that are just contrived or totally erroneous. But
Yep.
This gets to the fact that already today we have patients that are going to ChatGPT, that are going to Microsoft Edge, Bing, Creative Mode, GPT-4, and are asking about their relatives or themselves and getting answers. It's not regulated. It's out there. Does this need to be regulated or what?
Well, I don't know, because first of all, there's a big question. I don't know if we know how to regulate this. We're already hitting the hairy edge with regulating those convolutional neural networks. FDA barely could do that because in addition to specific tasks, there always was the question, how well reproducible is this in a different healthcare system with different patients and so on? Now we're talking about the whole of medicine with these multi-capable features. So it's not clear how to regulate it. But the other perspective is, in some sense, this is probably actually more systematic than Google search. Do we regulate Google search for medical use? We don't. And we know bad things have happened. because people see some kooky sites, and it's affected public health in a variety of problematic ways. And we don't regulate textbooks either. I think that it's going to be challenging. And I also want to point out that as people who live in the United States, we have a very localized view of things, because I am sure that China and Europe, for example, will have two very different views on how this should be regulated, and different from each other. We already see with this privacy legislation around search, for example, that Europe and China are different from us. And I think it's going to be also different there. So we do need to have a conversation about this. And I do think that it's good that the public can access these models just so they can see what it is.
Yeah.
And I think the worst outcome would be to have policymaking without general societal awareness of what these things can do and what their limitations are. And I don't know how else to have that legislation. I'm quite impressed by the fact that, despite what I like to think, I live in a bubble. Everybody around me is talking about GPT, and it's at this point almost boring. But then I was meeting several reporters who were visiting Harvard as part of an educational mission. It was reporters from very high-profile newspapers. They had heard of GPT, but none of them had actually tried it or used it. And so I do think that making it available for use allows the public and others to be part of a very important conversation. How do you make how do you make it safer? And there's some fundamental questions which I think are uncomfortable for some of the companies producing these models, like which data were used to train this model.
Right.
And OpenAI does not share that with the public. One of the reasons given is because this might allow the end of the world to happen faster. If we give the recipe to make these large language models, the AI that will then destroy the world could come faster, and it's seen as a public safety issue. But for example, do we know that there was no electronic health record data in GPT-4? We don't. We know it's not the standard web crawl that was been used in other models. And we just don't know what went into it. And that could affect biases, accuracy. And so I would start there, actually.
Yeah, this is an essential point. That is lack of transparency of the models. And this has been a real problem in medicine that's held back some of the progress and implementation. That it's a serious lack of transparency. Now, you're also touching on another critical point, which is that the large language models as they exist today, for the most part, we're going to talk about specialized fine-tuning. But, the ones we've been talking about so far were trained generically. There was no medical specific training. Maybe, as you say, maybe there was some, but we don't know of it. And now we're getting into models that are, basically piggybacking on the ones that took massive amount of pre-training GPUs and graphic processing unit computing efforts. And this, of course, is different because these are oftentimes startup companies, and they're saying, we're putting in millions of electronic records, and we're going to, do all this medical stuff. And now we have a different look here. If these startups are going to succeed, they may have to be more transparent because they are trying to make it into our space. And of course, there's many competitors, tens, if not hundreds, that are trying to have a place in medicine. And they go from more simple things like pre-authorization. And, you can see, I don't know what you think about this, Zach. We'll have AIs from doctors talking to AIs from insurance companies with no humans. They'll just talk to each other. Are we going to have our own AIs, each of us, that are modeled for our needs, whether it be our medical professional needs or our personal needs? Where do you see all this going as we get into all these specialized, fine-tuned models for our needs.
So I do think that we're heading towards a society of multiple such models. And that's because even within a single society such as ours, our values are not identical. You could imagine a AI large language model that was started the same as others, but then it was tuned more with some alignment around values that relate to less intervention, more alternative medicine approaches. And who's to say that that's wrong for those people? We can't prescribe a single type. And so I do think you'll see some, in fact, a lot of fragmentation officially of different products that are derived not only from the basic data, but from each other. Increasingly, we're going to be dealing with this weird information pollution, which is that right now, most of the content on the web is human. Pretty soon, most of it will be AI generated. And we already saw a great example of this. There's something called Amazon Mechanical Turk, where if you wanted to get a lot of tags or labels on some data, you could go through Amazon Mechanical Turk and hire literally thousands of workers throughout the world who for cents per label would label something or do some small task. So they get paid cents per transaction. So the market worked. And so a bunch of people started putting LLMs instead of humans onto those labeling tasks. So now we have a bunch of machine learning models whose labels they're getting not from humans, but from other machine learning models. Is that going to make it better, or is it just some weird black hole where you have just a bunch of AIs talking to each other? Sort of like you just mentioned, the billing AIs talking to the reimbursement AIs.
Yeah. Well, that's really interesting. And I guess as we wrap up here, because this is a fascinating discussion, I have to say, I don't know that I could have this type of conversation with any other physician colleague. Zach, it's just a joy. You mentioned, of course, the existential thing, and you also, I think, have a very sanguine outlook. You're not one, as I know you over the years, to be at all hyperbolic about anything. Where do you see the future here? Because obviously, we're talking about something that's probably more transformative than we've ever seen in our careers.
So a lot of my friends who, like you, know that I've been relatively sober about these things, have been a little bit taken aback by how excited I am about this. And they point out to me, that every big change has taken a while in technology to flow from the internet to the web to social media. So when I hear that, I say, it's true, but I want to point out every one of those things. Let's say if you go telephone, internet, web, social media, the uptake was faster and faster for each one of those transitions. And so I think we're in for even a faster transition. We're going to be now for an uncomfortable ride because the rate of adoption is going to be different in different parts of society. And narrowly in medicine, it's really going to be in different parts of medicine. So either it's going to end up applied broadly, or perhaps, and this would be a bad outcome, only high-end concierge services will use it because they want to give the highest customer experience and be plugged into latest in medical knowledge, and that the healthcare systems will be slow in its uptake. I hope that's not going to happen. I do think that hospitals are stuck right now in a very difficult place. They're under multiple constraints. They're losing money because the cost of ancillary personnel has gone through the roof after COVID. Frankly, the existing IT infrastructure is already incredibly burdensome for them. And so this feels, I think, if you're this chief information officer of a large hospital system, like another big ask. On the other hand, it is transformative. It's not going to just change billing. It's going to change the practice of medicine. And so I think there'll be large pressures. And overall, I'm extremely optimistic this will change medicine for good. I just don't know how to predict where it will happen most in this country or in other countries, and which part of the healthcare system.
Yeah, and I like the fact that you are thinking globally, and as you cited, the really two extremes, Europe being much more conservative and China being far more aggressive, and somewhat, of course, out of need, just because of, at least certainly in the medical space, there's just a shortage of clinicians to support their population.
That's right.
Yeah, I mean, I think this is, we're going to have to come back together for medicine and the machine in the stretch to see how fast this is taking hold. On the one hand, there's things there's desperate need where doctors and nurses are sick of being data clerks. And here's a remedy that, if validated, could be a really rescue for some of that, if not a large proportion. But then the other applications of taking this forward, which are just multipotent applications in many respects, we'll have to see. And whether any of these really get a foothold will be interesting.
So Eric, I just want to say one thing in closing. It's very obvious to me that the administrative part of it is going to happen almost immediately, because the risk, if you're a little wrong, what do? You lose a few dollars. And so the 30% of the medical economy in the United States is administrative overhead.
Right.
And so there's billions of dollars at stake. So in a purely self-serving way, every institution is going to benefit. Insurance companies don't have to have thousands of doctors reviewing cases. Hospitals will not have to have basements full of people upcoding. So that is something that's definitely going to happen. So unfortunately, as Willie Sutton was asked, why did he rob banks? Because he said that's where the money is. We know where AI is going to be first applied most broadly in medicine. It's in the financial administrative transactions. And our job and responsibility to society is to make sure that it should also work to improve the quality of healthcare.
Yeah, and I couldn't agree with you more. We saw how electronic records took hold just because of the billing issues, and
exactly.
We're going to see this, as you say. And as you know, my dream is that we free up physicians to have gift of time with their patients and actually feel like they're caring, developing that relationship that has been so much more compromised in recent decades, in fact. But we'll see how it plays out, and this has been fun. And the last point you made, which is, the out of need, the financial things that drive healthcare, which is a very big business. And this is a major unmet need. So, Zach, what a real treat to have this conversation. I know the Medscape folks who are listening or reading it will really enjoy. It's very informative, and we'll catch up again soon.
Thank you, Eric. Thanks for having me on.